Let's dive straight into our next exciting session, a keynote on edge AI and digital twins. To begin with, we have the keynote, and it is my privilege to invite our keynote speaker, Mr. Hitesh Garg, Vice President and India Country Manager at NXP Semiconductors. Mr. Garg is a leader in the semiconductor industry with a wealth of experience driving innovation in cutting-edge technology. His insights will undoubtedly set the stage for today's discussions. Ladies and gentlemen, let's welcome him with a round of applause.
Hello everyone, very good afternoon. It's my real pleasure, my first time to be in Vizag. This is a fantastic city. From my room I could see a nice coastline, and this morning I see the dignitaries on the dais, the Honorable Civil Aviation Minister and Shri Rajiv Chandrasekhar, I know him. The electronic revolution that we have in the country, I think it is his brainchild, so wish to thank him, and he is still our guiding light. He came to my office, I would say 2 years back, and he gave us, okay, how can we have Aadhaar authentication offline? So he has a mind of an engineer, he still gives us ideas, and I invited him for a keynote speech. In my innovation summit, Global Innovation Summit, there were top 200 NXP innovators along with my CTO, my whole CEO, and Rajiv made a pitch of 30 minutes. Everybody was talking to me, you have ministers like this. So we have never seen that minister can talk technology so much. So I think we are really privileged to have such great leaders who are technology drivers. Honorable Chief Minister of this state, I think we already discussed that he has also a great vision. So if somebody can put my slides, I think then I will start. So I think while the organizers are putting my slides, let me just start in the meantime. So I think the title of my discussion today is building smart autonomous devices for the world that anticipates and automates. I think we have, as I think the topic of this session is how we talk about edge AI. And so I think edge AI, as we see, so there are various challenges, various ecosystem challenges that we have in front of us, which we are trying to solve. And some of those challenges are, for example, we have climate change issues, we have infrastructure, we have to upgrade our infrastructures. There are new technology challenges, for example, AI. On one side, it's an opportunity, but it's also a challenge. Then also, everybody wants to stay connected. So when we look at these kind of problem statements, which are there for some time, but they are also evolving over time. So we need to build solutions. And I represent semiconductor industry, which is more of a horizontal industry. So there are various verticals, and we are transforming every sector. So I think if you talk about a year of 2000 to 2010, as the previous speaker mentioned, so it was age where the compute was the key driver. So compute like Intel's, and so those companies, they were driving the whole growth in semiconductor. When we came to the year 2010 to 2020, this was the era when mobiles were the key driver for the whole of electronics or semiconductor industry. So in era of 2020 to 2030, right? So this is the era when AI, edge AI, are the key drivers for us to be ahead in the game. So today the semiconductor industry is in the range of $600 billion, and the target by 2030 is that the semiconductor is going to be a $1.2 trillion industry. So just in 6 years, because of the applications, because of the I would say the opportunity that we see around us, the semiconductor industry is going to double. And Honorable Rajiv Chandrasekhar, he already talked about the AI, the new things that we are coming, the opportunities in the system area that we have. So I think those things are going to help us. Somebody if can give me a slider. If you can go to the third slide, please. Yeah. Oh, sorry. Thank you. So this is what I was mentioning. So this is an era from AI to the cloud to the secure edge is driving the growth of the semiconductor industry in this decade. And our target by 2030 is $1.2 trillion of industry. Right? Moving on. So if I say how we are transforming each and every sector. So these are the key opportunities that we see, right? So we are getting digital twins. We are getting digital twins in each sector. Whether we talk about industrial, you talk about healthcare, you talk about home automation, you talk about automotives. So I think we are building robots, right? So we are sensing, we are computing, we are putting the data on the edge, on the cloud, and then we are processing. So I think this is a structure that we have everywhere, right? From the technology axis, it is on one side you can see multiple applications, but for us it's very simple. Very simple to see that the way we see it is about sense, think, connect and act. We have to have sensing, we have to have thinking technologies, we have to have connectivity, and we have to have actuation technologies. So I think that's where any of the industry we can transform. At the same time, there is a great opportunity but great challenges. Every industry provides or throws us different challenges in front of us. So here what we see is by 2030 there will be more than 50 billion smart connected devices. Right? So smart connected devices, so it will be in your homes, it will be in the industry, it will be in the transportation industry, it will be on the medical line, so everywhere you will see connected devices. And as I see, the challenges in every sector are different. For example, when we talk about industries, you need to be functionally safe. Whatever the work, whatever the technology solutions that we cook for the industrial, it should be functionally safe. When we talk about transportation, it should be functionally safe, but it also has to process in real time. If there is a car which is running at 200 kilometers per hour, there are sensors. If there is somebody in front of the road, the processing has to be happen in the real time. Right? The sensor has to detect, the processing has to happen, and the brakes has to be applied. Everything has to happen in the real time, and it provides real different challenges. Systems on the home automation side, right? It has to be secure. You don't want your homes to be hacked. Similarly, on the personal devices, you talk about medical electronics or you talk about your mobile phones. So there, the trend is how can we have solutions which are low power. So these are the challenges which are there because of every field, but at the same time the solutions are similar. So I will go into the use case of automotive, right? So just to drill down into these details. Otherwise, it look like okay, so some use cases with electronics. So what is happening in automotive? What are the key drivers that we see in automotive? So one key driver is autonomy. I think Tesla has kind of given us a vision that we would like to sit in the autonomous cars. We want to drive the autonomous cars. The second trend is electrification. We want zero emissions. The cars are going more and more electric. And third is connectivity. We want our cars to be fully connected, zero time wasted, intelligent transportation system. So these are the key trends in automotive which are transforming this automotive industry. And as I was mentioning this earlier, so these are the 4 technology pillars that we have in front of us: sense, think, connect and act, right? Around which we think like human robots, we build our technologies like human robots. At the same time, everything has to be safe, secure, and these solutions should be scalable. One of the things, right, we should see when we talk about sensing, the sensors should be better than human sensors. Whatever the sensors, for example, right, when you are driving the car, so the sensor that I put in the car, they should be better than the human sensor. Whether it's a camera sensor, whether it's a radar sensor or a LiDAR sensor, it should be more accurate, it should be better than a human. Then only I can depend on those sensors. So I think that provides unique challenges, but at the same time, unique opportunities. When I come to the compute, you can say there are various ways, and I have put the analogy of the brain. So there are three layers in the brain, right? We call cerebrum, and brainstem. Lot of your motor activities, right? Whatever that you have to do, for example, if I am just walking on the stage and if I trip, my body will recover automatically, right? So all those motor functions, they are all done in cerebellum or brainstem. But once the body will recover, but then I will look back and see, okay, what was the reason that I tripped? Then the human will start processing. And that processing is happening in cerebrum, which is the top part. So some of the insects, like they even don't have a cerebrum. And here, when I talk about cerebrum, it's more like AI or advanced computing. So you need the basic computing which is there in your body, or at least the lower part of the brain which is required. And many of the insects, they even don't have a cerebrum. So the point which I want to make is, for every application you don't need advanced processing. You need some basic processing, and I think the coordinate action, vital, criticals. And I think so we need to identify that what level of processing, what level of things we need to have. And that's where Edge AI provides a very, very important role. So a lot of functions that we can do on the Edge AI. We don't need a high-end processors. I think so that's where I think this 50 billion smart connected device provides a great opportunity for all of us. Right, so this is just a summary of how from the low end to a medium end to a high end processors that we have. So the biggest brain of the computer is our 5 nanometers S32N processor. It has more than 4 billion transistors, right? This is the real-time brain power of any automotive engine. And then going to S32K1, which goes into each and every function from motor control to it. And then this is plethora of things that we have. When we talk about cars, right? So the cars are evolving. And the minister talked about, okay, Tesla, then minister also talked about Mahindra. And recently you guys might have heard about this new Mahindra EV which has come, 6V, it's called Born EV or 9V, whatever the name. So we are from NXP, we have more than 40 devices into that car. Right, so these, again, that's just to mention that a lot of innovation on the system side, on how we build these kind of complex system, is happening in India. A lot of those designs which goes into the real use cases, so they are all designed, developed in India. So I think the car, I got an opportunity to meet the CEO of Mahindra. So and the discussions were, okay, what kind of, and discussion was exactly on the same topic. When we go to a software defined vehicle, what kind of architecture should we choose? Should we go with a domain-based architecture? Should we go with a zonal-based architecture? Should we do a mixed mode architecture? So I think, so this is what the car companies are deciding. So they own the architecture. As we go to the SDVs, as we go to the advanced cars, so the OEMs, the Mahindras, the Tatas, the BMWs of this world, they own how the architecture should look like. And then they invite us, okay, where we put the brains, where we put the kind of legs and all those kind of things. And as I said, every car OEM is different. They would like to have the car architecture completely done in a different way, right? So when you say there are 50 OEMs and they are doing these car architectures in a completely different way, we need to make sense out of it. We need to provide our solutions which are scalable, which can fit into every car OEMs, right? And that's where I think we also, hardware is not the only thing. We need to also think about software solutions. And that's where I really thank the minister, because he mentioned about the need of a system solution. I think India has done a fantastic job in defining or at least growing the software industry. in growing the semiconductor industry. So we have 25% of the semiconductor engineers are sitting in India. So we have grown very, very well. But I think this is the next boom, or the next need is to have system engineers who can think in terms of system. We need hardware and software engineers to talk to each other, to build design systems for India, for the world. And this is just one example, and the complexity is going to go up. So if you scare complexity, I think then this is not the field for you. Every day, every year you have to learn. You have to learn various domains. You have to learn software. You have to learn hardware. And I think a lot of the startup guys, I have my friends here, so they are on this difficult path. But I think this is the way, this is the only way that I see to win, right? So system integration, how we define design software to take care of the system integration challenges. So I think just to sum up my discussion, right? So we talk about edge AI. So these are, you can say, software defined robots in any field. You talk about automotive, you talk about industrial, you talk about healthcare, you talk about home automation. So the applications can be anywhere, but I think one is that we need to start thinking in terms of systems. They should be real time. There should be a safety consideration. Sensors, they should be better than the human sensor. Then only we are better than them. Trust, we need to have built-in trust provisioning there, right? AI, machine learning. So how can we use these things for real computation? And then they should be able to scale up for various different architectures. So I think any solutions that we cook, you cannot make one solution for every application. We should also think of building scalable solutions. So with this, I think I thank you all, and so thank you for, and wish you a great conference. Thank you very much.
So please. The future of edge AI. Your perspectives on innovation and its real-world applications are truly inspiring. Thank you so much. I would like to invite Mr. Sridhar Kambala, Director of Technology, Evolutus, to do the honors of felicitating our speaker, Mr. Hitesh. Ladies and gentlemen, let's welcome Mr. Sridhar with a huge round of applause. Welcome, sir. Okay, thank you so much, gentlemen. Yeah, the photographers here, sir. Please.